Good afternoon, students. How is everyone doing? So, in the last class, we covered how to select objects when we have to take at least one of them, right? When we have to select at least one of them, then how can we find the number of ways of selecting? Today, we are going to select exact number of objects. So before we start, is the audio fine? Is the video fine? Just let me know so that I can start. All right. So without wasting any more time, we are going to see the exact kind of question I'm talking about. So yesterday we had a bunch of fruits and we had to select at least one out of those, right? Today we have to select exactly 4 fruits out of our given fruits. How many fruits do we have? We have 6 apples, 5 mangoes and 4 bananas. Now we have to select exactly 4 fruits out of them. How many ways to do that? Either we can select 0 apples and let's say 1 mango and 3 bananas, or 0 apples, 0 mango, 4 bananas. Like that we can have a lot of different options, right? One way to do this is by finding the combination. We have to find x number of apples, y number of mangoes and z number of bananas such that the sum of these 3 numbers comes out to be 4, right? Now, what is the condition for x, y, z? It can be 0 or 1 or 2 or 3 up to 4, right? So that means for x, y and z, we have either, now without worrying about the order, what are the 3 numbers? Without worrying about the order first, what are the 3 numbers that can sum up to 4? It can either be 0, 0, 4. Remember from the first class, in order to count all the cases, we have to follow a certain order. In this case, I will follow the ascending order. Okay? So that means we first fix the first 0 and then 0, 1 and the remaining will be 3. 0, 2, 2. Now I will not count 0, 3, 1 because I've already counted again, because the order doesn't matter. I'm just checking what 3 numbers can I pick so that their sum is 4. Okay, so we are only following the increasing order. We will not follow 0, 3, 1 because that will increase and then decrease. So it always has to be increasing. We have reached a point when this was decreasing, this was increasing, so they are equal now. The next one will be, this will be more than this, 0, 3, 1. So time to change the first digit. Now it's 1. Now again, it cannot decrease, now it only has to be the same or increase. So 1, 1, 2, or that's it, because if we move on to 1, 2, then the last one will be 1, increase and then decrease. So we're done with 1. Which means now if we do 2 and then 2, the last one will be 0, it will decrease again, so even this will not be counted. But in order to count all the cases without repetition, we have to follow a certain order. So these are all the cases that we can get, right, without order. Now let's order them. How many orders for this? 4 can either be in the first position or the second position or the third position. Now we have 0, 0, 4 or 0, 4, 0 or 4, 0, 0. So how many? 3 factorial divided by 2 factorial, because two zeros are identical. Similarly 0, 1, 3, this will have 3 factorial. 0, 2, 2, again 3 factorial by 2 factorial, and 1, 1, 2, 3 factorial by 2 factorial. So we get 3, 6, 3 and 3. In total 50. So that is one way you could have done this, right? Just by logically, by counting, by using what we have learned so far. But how else can we look at this? We had to count all the possible cases. What if this number was more than 4? What if this number was much larger? In that case, we would have to count a lot more, right? So let's look at another way. We have so many ways of doing this, and we are going to take our sweet time on this question because we want to cover all possible methods. Yes, okay, yes, is this live? This is live. It is live. I just wasn't paying attention to the chat because we cannot break the flow. While I'm explaining a solution, I don't want to break the flow. Once I'm explaining a solution, I will be focused on that, but that is why I will not read the chat in the middle. Anyway, yes, please go ahead. What is the doubt? I don't know what your doubt is, Vichi. Come on. You're studying in 12th. Should I prepare for IOQM? If you're preparing for JEE and if that is your goal, you should focus on that. Anyway, you should not like Olympiad should be lower priority if JEE is your goal, Vichi. Alright. So this is clear, right? It was a tedious process, but we reached the answer. The answer is 15. Alright, now let's take a look at another method. Now, if we fix the first one, let's say 0. Now the remaining two have to be equal to the sum of the remaining two has to be 4. If I fix this one, then I know this one, right? It will be 4. If it's 1, I still know this one, 3. So all I need is how many options do I have for the mangoes? If this is 0, then how many options do I have? I have 0, 1, 2, 3, 4. It can go from 0 to 4, right? And I will still know the last one. So for each of these cases, there is exactly one possibility for bananas, for Z. So that means for 0, I get 0 to 4, that is 4 plus 1, 5 options. If I fix this to 1, now the remaining sum needs to be 3. That means now this can go from 0 to 3, and as soon as I fix this number, I know Z. So how many possibilities for this? 4. How did we get 4? 3 plus 1. So similarly for 2, the sum will be 2. So 0 to 2, 3 and so on, right? The next it will be 2, and lastly once I fix it to be 4, then it will have to be 0, 0. So exactly one case possible. So how many cases in total are possible? 5 plus 4 plus 3 plus 2 plus 1. Because it's a small number, you can add them, we get 15. Or if it were a larger number, then we can use AP or sum of series formula, however you feel comfortable. So for sum of series, we have 5 into 5 plus 1 by 2, right? Number of numbers 5, so n into n plus 1 by 2. Again, that is 15. So that is another way of looking at it. Also correct, because we're getting the correct answer. We did not miss any case, we did not count any case, repeated any case. So that means this is also correct. So this is the second method of doing this. Now let's take a look at another way. Just a second. Now we need to select 4 fruits, right? So that means we have to partition this such that the sum of these x, y, z is 4, right? Before we understand how to actually do this, we will look at another problem, okay, just to see what the question, what kind of questions we are looking at. All right, so we'll come back to that question. We have 2 more methods to discuss for that problem. We will come back to it, but let's first see all of such problems, and then we are going to combine the methods and see how they work for all of them. So now, for example, we have a word mathematics, right? This is mathematics. I've just arranged like letters together. So now that means we have 2 M's, 2 A's, 2 T's, 1 H, 1 E, 1 I, 1 C, 1 S, right? We have to form 4-letter words with or without meaning, right? With or without meaning. So how many 4-letter words can we form? We have total 1, 2, 3, 4, 5, 6, 7, 8. We have 8 letters and 3 are available twice. So what are the options we can have? Either all letters are distinct or 2 letters are same. Now all letters are distinct, that is one case. Another case is 2 letters are the same and then the other 2 are different. We can order them. It can be L2, L1, L3, L1. We will check the ordering, but once we are selecting the letters, in that case we are only checking how many are similar, how many are identical and how many are distinct. Then another case is 2 are same and the other 2 are also same. Now more than 2 letters of the same letter are not available. We cannot have 3 of the same because 3 of any letter is not available, right? Max we have 2 M's, 2 A's, 2 T's. So these are all the cases we are going to have. That means we have, how many options do we have for selecting 4 distinct letters? We had total 8 letters available. 8 distinct letters are available to us. So we have to select 4 out of these. And once we have them, then we have to arrange these, all possible options, all possible arrangements. So multiplied by 4 factorial. In this case, we have to select one such letter which is available twice. So out of 3, we have to select 1. So 3C1 into for the other 2. For the other 2, how many options do we have? We don't just have these 5 options, but we have 7 options. Once we have selected L1, that is gone, but we can still, let's say we chose M. So M is gone, but we can still select A1s to T1s or out of these distinct letters available, right? So for these 2, we don't just have 5 options, we have 7 options, 7 remaining options. So we will select 2 out of those 7. And now we're going to arrange these. How do we arrange these? 4 factorial divided by 2 factorial, because these two are identical. Now for the last case, we have to select 2 letters. Just 2 letters, one L1, one L2, such that these letters are available twice here. How many letters do we have like that? 3. We have 3 such letters, M or A or T. We cannot select H or E or so on now because we need the same letter twice. So out of these 3, we will select 2. So 3C2, and once we have the 2 letters, we are going to arrange this. So 4 factorial divided by 2 factorial, 2 factorial. And we will just add this up and we will get our answer. Alright. So what's the answer? I think you can calculate, right? Someone says 2, 4, 5, 4. Okay, if you want to check, let's check. But I know you can do that very easily. And that comes out to be, for first case, we have 8 factorial by 4 factorial, that is 8 into 7 into 6 into 5, which is 1680. For second one, we have 3 into 7 into 6 by 2, 21 into 4 factorial by 2 factorial, that is 24 by 2, 12. This comes out to be 63 into 6, 756, right? And for the third case, we have 3 into 4 factorial by 2 factorial, 2 factorial, that is 6. So in total 18. So we get 2, 3, 2, 4, 3, 6 and 2, 4, 5, 4. That is correct. Very good. That's the answer everyone's getting? Yes? Perfect. So this is another way of doing this kind of problem by making sure you're counting all the cases one by one. Either all are distinct or 2 are similar or 2 are similar, 2 are similar. If we had more such options, we are going to count in that order. Okay? We'll come back to the first question, don't worry. But let's take a look at another kind of problem which will happen to be very similar. Now, what is the problem that we have? Earlier we had to select exact number of objects. Now we have to distribute the objects. Okay? So, distinct objects. Right now in this problem we have 5 different ice creams. Okay? We have 5 different ice creams and we have to distribute them among 3 students without any restrictions. That means even if some students do not get any ice cream, that is also one possibility. But we have to finish the 5 ice creams. We have to distribute them. Total should be 5. So now x plus y plus z is 5. The first student gets something, the second student gets some number of ice creams and the third one gets some number of ice creams. Again, we'll order them. Right? We'll start with 0 and then the other one also gets 0 and 5. Or now, if we just count all the possible cases, it might be a lot of work. Why? Because we are not done here. This is not just one case. Okay, this is one case. But the next, let's say, there is 0, 1, 4. Now, this is not just one case, but actually, which one ice cream is this second student getting? We have 5 different ice creams, 5 different flavors, 5 different brands, just 5 distinct ice creams. And now second student has to get one of them. But which one? We also have to see which one, right? So that is why we can't just list all of them. In that case, we'll have to count all the possibilities for each case. So we are going to do the first method. We're going to see how we can find all the possible combinations of numbers, and then we'll see the possibility of finding the ice cream, selecting the ice cream, and then arranging it within these 3 students. Okay, so let's start. First of all, first step is which 3 numbers sum up to 5? Which 3 numbers sum up to 5? 0, 0, 5. Then we go 1 up, 0, 1, 4, 0, 2, 3, and that's it. 0, 3, 2. We're not doing it because it is increasing and then decreasing. We've already counted that. We're going only in one order so that we don't repeat any case. Then we move on to 1, 1, and remaining 3. 1, 2, 2, and that's it. Then no further case will be there because 2, 2, and then 1, we've already counted this. So these are all the possible cases, right? Now we have to find how many ways of selecting the ice creams. So here we have to select first 5C0, then out of the remaining 5 we select 0, out of the remaining 5 we select 5. Here we first select 0, then out of the remaining 5 we select 1, out of the remaining 4 we select 4. I'm just doing the proper way. Of course, logically you will not do all of these steps. You know that this is just one case possible, all 5 are going to this. In this case we just have to select 1, the remaining 4 will go to the third student, or however we arrange it. Then for this we have again same logic, 5C0 into 5C2 into 3C3. Now 5C1, we first select this one ice cream, out of the remaining 4 we select this one ice cream and the remaining 3. So now I don't have to do the last one, right? It will always be one possibility. If we have selected these, then the remaining ice creams will go here. So I'm not going to write this anymore, and now we have 5C1 into 4C2, and that's it. Now for each of these cases we also have to see how many arrangements are possible, right? So okay, we have selected the partition. Now we have the ice creams. We have one set of 0 ice cream, another set of 0 ice cream, and another set of 5 ice creams, or in this case one set of 1 ice cream, one set of 1 ice cream, and one set of 3 ice creams. We have this. Now we have to arrange it. We have to see all possible arrangements, right? So we have to arrange all of these within the 3 students. So now here we will do 3 factorial by 2 factorial. Here we have 3 factorial. Here we have again 3 factorial. Here 3 factorial by 2 factorial. And here again 3 factorial by 2 factorial. Alright, so we'll just add these up and we'll have our answer. What's the answer that we're getting? Here we get 1 into 3, so 3. Here we have 1 into 5, 5 into 6, 30. Then we have 1 into 5C2, 10 into 1, 10 into 6, 60. Then 5 into 4, 20 into 3, 60. And then we have 5 into 4C2, that is 6. So 5 into 6, 30 into 3, 90. We'll just add these up and we'll have our answer, right? Is that what everyone is getting? Yes? Is there any doubt? So yes, bache, we have to count a lot of cases sometimes, but if each case is going to be handled separately, then we have to list all the cases, okay? If we can just find how many cases, how many possible partitions can be there. If the ice creams were identical, then it was the same solution as before. We just had to see how many numbers are possible in this case. But now we also, before arranging them, we also had to see how to select the ice cream. So then we had to count all of these. So it's 243, what are you getting? Okay. 122, 10243, yes. So the answer is 243. But the method is more important. how we are actually making sure that we're counting all the possible cases in an order. We're not going to do this randomly, okay? So that is the most important thing. If you do it randomly, it is very likely that you will miss some cases, or you might end up wasting some time rechecking if you counted everything, if you missed anything. But if you go in an order, then it is very helpful. You will make sure that you're counting everything. All right. Now, coming back to the like object partition, right? Coming back to this like thing, when there are identical objects, like objects, identical objects, coming back to the original problem, if though they were 5 identical ice creams and we had to do it, such kind of questions, how do we deal with that? Okay, so let's say we are distributing 5 like balls into 2 people. Okay, 5 like balls into 2 people. That means we have 5 identical, say, blue balls, and we have to distribute it among 2 people. Now, that means, let's say the first one gets x, the second one gets y, and we have this. The same kind of equation we keep getting, and now we have to find a solution to this. Okay, so now we are going to discuss how to actually find a solution to this problem. There's a direct formula and there is a long derivation which is going to make sure that you will count all the possible cases whenever we cannot apply the formula directly. So first, let's see the formula. Okay, so in this case, this is very easy. We just counted this. For x plus y equal to 5, x can either be 0, and as soon as we fix the first one, the second one is clear. It has to be 5, right? If we fix it to be 1, then we know why. It has to be 4. If we fix it to 2, we know what y is going to be. So how many options for x are there? 0 to 5, that is 5 plus 1, 6. And for all of these 6 cases, there is exactly one possibility for y. That means in total 6 ways of distributing these 5 balls, 5 identical balls into 2 people. Okay, so in total we have 6 cases, right? So this is one way of solving this that we have already discussed when we are counting in a way all the possibilities. Now another way of looking at this is, let's say I have to put a partition in this, right? If I put the partition here, that means the first student gets 2, the second student gets 3. If I put the partition here, that means the first student gets 3 and the second gets 2. They are different cases, so we have to count them separately, right? Because the students are not identical, the students are obviously different. Now, there's also a possibility that I put the partition here. What does this mean? The first student gets nothing and the second student gets all of it. Or the first student gets all 5 and second student gets nothing, right? So that means as soon as I put a partition here, we have the exact distribution. So we can see it in a way. In one way of looking at this is, we have 6 possibilities of putting the partition, right? 1, 2, 3, 4, 5, 6. We have to select one out of these 6. So 6 possibilities, 6C1, that is our answer, right? So again we get 6. Another way of looking at it is, now this is the most important one. We have 6 things to arrange. We have 5 balls and 1 partition. So in total we have 6 objects to arrange. As soon as we find one arrangement of these 6, let's say it comes out to be this arrangement, this is a unique arrangement. Like this, we'll have all different unique arrangements, and that will give us a unique distribution between the 2 students, right? So How many ways of arranging these 6 objects are there? 6 factorial divided by 5 factorial, because 5 of these 6 objects are identical. So we get 6. Alright. Now, let's take it one step further. We had 5 balls just like before, but now we have to distribute it among 3 people. X plus y plus z is equal to 5. Similar to our previous problem, if the 5 ice creams were identical, or if we change this 5 to 4, then it brings us to our first question, right? Now, we can count all the possible cases, but if we just do the partition thing again, how many partitions do we need now? We needed 1 partition for 2 people. We will need 2 partitions for 3 people, right? If we have 2 partitions here, that means the first one gets 2, the second one gets 1, the third one gets 2. Or we can have something like this. Both the partitions are here. What does that mean? The first one gets 4, the second one gets nothing, the third one gets 1. So, by arranging 2 partitions, by finding the position of these 2 partitions, we will find the unique distribution. So, how many ways of arranging these 2 partitions here? We have 5 plus 2, 7 objects. So, we have to arrange these 7 objects, 7 factorial divided by 5 balls are identical, 2 partitions are identical. So, 7C2, this is nothing but 7C2. So, with this, we get a formula that if we have to arrange, we have to find these 3 numbers, x plus y plus z. If we have, in general, if we have x1 plus x2 plus up to xr, we have to distribute this n. We have to distribute this n into r different partitions such that their sum is n, and all these x1, x2, x3 and so on are non-negative integers. Alright, so if just like before, x plus y plus z, they were all 0 or 1 or up to n, because it cannot be negative, so the maximum it can go is up to n. So each of them can go from 0 to n, 0 to n, 0 to n. So we get a direct formula that we put n plus r minus 1 partitions, right? N objects, r minus 1 partitions, and we arrange these divided by the n objects and r minus 1 partitions. So this is nothing but n plus r minus 1 c r minus 1. This is the formula. Okay, so going back to our first question. Now we have n is 4, r is 3 minus 1 c r minus 1. So we get 4 plus 2, 6 c 2. That is 6 into 5 by 2. Again we get the same answer, 15. So this is the same as distributing 4 objects into 3 different partitions, right? So this is another method. Now one last method, which might be the trickiest, but it is the ideal way of looking at it, because this is how we can solve any given problem like this, where we have to solve an equation. How do we do that? But whoever has a problem understanding, I'm taking it very slow so that most of you can understand. If you still feel, that's the beauty of a recorded session. You can always go back to it, listen to it again. You're just asking me to repeat, but that's the beauty of technology. Now you can just make me repeat again yourself without me actually having to do that extra effort, right? So if you have any problem understanding something that I already explained, you can always go back and listen to it. I'm sure you will get it. Okay, just give it some thought, think about it yourself, and you will get it. Now the most important part of today's class: how do we actually solve any such problem? That is called a multinomial theorem. x1 can go from 0 to n, and similarly x2 can go from 0 to n, xr can go from 0 to n, right? So for x1, how many options do we have? X raised to power 0, x raised to power n, and like this we have for x2 as well. We have this for all our variables, and once we multiply this, but we will have a lot of terms in this multiplication, right? We will have x raised to power 0, x raised to power 1. We will have all possible exponents of x with different coefficients, but we need to find the coefficient of x raised to power n in this. Why? Because what will that do? We will get some value from here, some value from here, some value from each of these r, and that will form one case. As soon as we multiply all of them, the exponents will add up, right? Exponents will add up. For example, if we look at our previous problem. X plus y plus z is equal to 5. We are saying we need coefficient of x power 5 in x raised to power 0, x raised to power 1 up to x raised to power 5 raised to power 3. Because we have 3 variables, we will multiply this 3 times. Now let's say we pick this 0 from the first bracket, we pick 1 from the second bracket, and 4 from the third bracket. So we get one such term where the coefficient is 1 right now and the power of x is 5. So now in how many ways can we pick such terms such that this x raised to power 5 is what we get? That is what we mean by coefficient of x raised to power 5 in this expression, because the number of such terms, such combinations, that will be, all such terms will be added, right? All such terms will be added. We will also add x raised to power 0, x raised to power 5. This will also give 1 x raised to power 5. We will get 1 x raised to power 5 from here. We will also get 1 x raised to power 5 from here, and like that, right? So that means the total number of combinations, that we can have, the arrangements that we can have, that will be the coefficient of x raised to power 5, because that many times we are adding the same term again and again and again. Okay, so that is why the ideal way of doing such problems is we have to find the coefficient of x raised to power n in this. And how do we make these brackets? We write in power all the possible values that these variables can take. Okay, so like here it can take 0 to n, so we wrote all the possible. If it could not take, let's say, few of these values, then we will skip those values. Alright, even here we took all possible values for x. So now let's just solve this. Once we solve this, one bracket we get, it's another GP. So with common ratio, x. So 1 minus x raised to power, how many terms? N plus 1 divided by 1 minus x whole raised to power r, which is equal to 1 minus x raised to power n plus 1 whole raised to power r into 1 minus x raised to power minus r. Now, bache, if you know binomial theorem, then it's easy for you to understand how to find the coefficient of x raised to power n in this. If you don't, then I suggest that you study it up, because today is not the class we get into binomial expansion entirely, which is why I'm just going to tell you how to expand these, how to get the coefficient. But if you are not comfortable with it, you haven't studied that topic yet, then I suggest that you first study that topic and then it will be very easy for you to understand. This becomes very easy problem. So now in the first bracket we get 1 minus r into x raised to power n plus 1, and then we have rc2 x raised to power n plus 1 square and so on. We need the coefficient of x raised to power n. If we multiply x raised to power n plus 1 with any terms, here we are only going to have 1, then x and higher powers of x. If we multiply this with this, any terms in this with this, we will get x raised to power n plus 1 or n plus 2, like higher powers. We need x raised to power n. It is impossible to form x raised to power n from this. That means we will ignore all of these. Why will we ignore? Because it's impossible to form x raised to power n from any of these terms, so we will only consider 1. That means what will be the final coefficient of x raised to power n here? The coefficient of x raised to power n here multiplied by 1. So now our new problem is coefficient of x raised to power n in 1 minus x raised to power minus r. This is our problem, and there is a direct formula for this, that is n plus r minus 1 c r minus 1. So that is how we will get the same answer. Yes, of course we have to get the same answer, this is correct. But why did we do all of this complicated thing then? Because here we are assuming, but very carefully you have to remember the conditions. While memorizing any formula, it's very important to memorize the conditions as well. When can we use the formula? The condition is all of them go from 0 to n. Alright. Now, if that weren't the case, if there were some specific conditions, not every variable could be from 0 to n, in that case we will need this multinomial expansion. We will have to write all the possible cases and we'll have to see the coefficient of x raised to power n in this. So this is how we do it, bache. If this is new to you, if you're having difficulty understanding this, I suggest you go through this after the end of the class again, revise it, understand it in depth. If you don't know binomial yet, then I suggest you at least read some formula, some expansion, some basics of it, and then come back here. It will be very easy for you then. Alright. So now let's take a look at some examples. Okay. Try this. We have using any method, okay? I think you can easily do it using the formula. Just make sure that we can apply the formula. So what is the question? The number of ways of distributing 10 mangoes among 3 students without any restriction. All mangoes are identical. What's the correct answer? Very easy. Come on. Try again, bache. It's not A. I know we did a lot of complicated things, but this is very basic. The formula, you can apply the formula directly here. What do we have to do? We have to distribute 10 mangoes among 3 students. That means we need x plus y plus z is equal to 10. Right? Now, we have to distribute this among 3 students. So, this is our equation. What is n? 10. What is r? 3. What is the formula? N plus r minus 1 C r minus 1. So the correct answer becomes, thank you, B. So, alright. When can we apply this formula directly? When we are talking about identical objects. Okay. Then it's just solving this equation. Another way of looking at it was, we have to just find the partition for the 3 students. So, we will arrange these 10 mangoes and 2 partitions. So, we arrange these 12 in total objects divided by 10 factorial for the 10 identical mangoes and 2 factorial for the 2 identical partitions. So, this is nothing but 12C2. Whichever way you find more comfortable. Of course, that seems, I think, the most comfortable, the most easiest to understand, right? So, bache, whichever you feel is easiest to understand, but you should be able to apply at least one of these methods, right? So, that is how we can solve this. Okay. Now, find the number of ways of distributing 10 mangoes, 6 apples and 4 bananas among 3 students such that every student gets at least 1 mango. Try this one carefully. Think logically, do not try to rush the answer, okay? Let me get aside so that you can see the options. No, bache, D is not correct. Try again. No, carefully, carefully. Think very logically. C is correct, yes. And Dhairya, are you the one who attended my recent VIP session as well for greatest integer and calculus related thing? Is that? Because I know one Dhairya, but I'm sorry, I don't know your last name. Okay, but hi. I'm glad that you're attending this session. I hope you get to learn something here as well. Now, coming back to the question, C is correct. Okay. So, how do we do this? Now, it's a similar problem. We have to distribute 10 mangoes. We have to distribute 6 apples. We have to distribute 4 bananas. They're not related, they're independent. We first distribute the 10 mangoes and then it doesn't matter who got how many mangoes. We start again and see how many possibilities for distributing these 6 apples. And again, start again. We don't care what any student has got, we'll see how many possibilities for distributing 4 bananas. Alright, so, but the problem here is, first we have to see, okay, step by step. 4 bananas we have to distribute among 3 students. So 4 bananas plus 2 partitions. So 6 objects and 2 partitions. Or we can say x plus y plus z is 4. So 4 plus 3 minus 1, C 3 minus 1. So 6 C2 ways of distributing the bananas. Similarly for 6 apples, there are 8 C2 ways of distributing. Same way, right? X plus y plus z is equal to 6. So 6 plus 3 minus 1, C 3 minus 1. Same formula. Now we have a condition. For mangoes, if there were no condition, we could have directly done 12C2 how we did in the previous question, right? But now what is the condition here? The condition is that at least one mango should be given to all of the 3 students, which means x plus y plus z is equal to 10. In this equation, now we have a condition. Earlier, all of them could go from 0 to 10, 0 to 10, 0 to 10, right? But now each of them will go from 1 to 10, 1 to 10, 1 to 10, right? So that means now we cannot apply the formula directly. What we can do is, there are 2 ways of again looking at it. In combinatorics, there will always be multiple methods to look at it. So in this, how many ways can we do this? First, we give 1 mango to each of these, okay? So we had these 3 students and we give them 1, 1, 1. How many do we have left? We have 7 left. Now we have to see the remaining x, the remaining y, the remaining z. Each has at least 1 now. Now the remaining x plus y plus z has to be equal to the remaining 7. Now x, y, z can be 0 as well, because we have made sure that they all get at least 1. So now x, y, z can go from 0 to 7. So that means this will be 7 plus 3 minus 1, C3 minus 1, which is 9C2. So instead of 12C2, we get 9C2. And because they are independent and we have to distribute mangoes and we have to distribute apples and we have to distribute bananas, so we will just multiply the 3 numbers. Why we were not doing this? Because this is excluding just one case out of all of those, right? We multiplied all of them and we're just excluding one case. But we're not just counting one wrong case. We're counting multiple wrong cases because what all cases we need to exclude? We need to exclude the cases where any one student gets a 0. Gets 0 mango. Any one student. It can also, it's not just 0, 0, 10. It can be 0, 10, 0, 0, 1, 9. Even this, all of these are being counted. That should not be counted. So instead of checking how many cases are we miscounting, we will directly just give each of the student 1 mango and then distribute the remaining 7 mangoes. Alright. Now another way of solving such problems is x plus y plus z is equal to 10. We have a new condition. X has to be greater than equal to 1, y has to be greater than equal to 1, z has to be greater than equal to 1. Okay. So now we take a new variable which is equal to x minus 1. Now this is greater than equal to 0, right? Y dash, we also take y minus 1 which is also greater than equal to 0, z dash which is z minus 1, this is also greater than equal to 0. So in order to make these x dash, y dash, z dash, we subtract x minus 1, y minus 1, z minus 1, and because we subtracted 3 minus 1s here, we also have to subtract 3 minus 1s here. So now our new problem becomes x dash plus y dash plus z dash is equal to 7. Now we can apply the formula directly. 7 plus 3 minus 1, c, 3 minus 1, that is 9c2. So in general, if any equation has this kind of conditions, then we can solve it this way. So now let's say if I had x plus y plus z is equal to 10 such that x is greater than equal to 1, y is greater than equal to 1, z is greater than equal to 2. Then what will be the answer? Use the same logic as this and answer in the chat. With practice, bache, with practice you can increase your calculation speed. But first of all, try to answer this question. The solution is literally up there. You just have to understand how we can form a new variable. All the new variable needs to satisfy is, the entire condition is, it should go from 0 to n. See, x minus 1 is greater than 0, y minus 1 is greater than equal to 0, z minus 2 is greater than equal to 0. So our new variables will be x minus 1, y minus 1 and z minus 2. So we'll make this here x minus 1 plus y minus 1 plus z minus 2. What all did we subtract in the LHS? 1, 1, 2, total 4. So we will also subtract 4 here. So this means x dash plus y dash plus z dash is equal to 6. So that means now we can apply the formula, because now x dash is greater than equal to 0, y dash is greater than equal to 0, z dash is greater than equal to 0. All of these variables can go from 0 to 6, 0 to 6, 0 to 6. Okay. So now we'll apply the formula directly. 6 plus 3 minus 1, C3 minus 1, which is 8C2. Good. So now directly applying the formula and seeing what we did, let's just look at some more problems. So this we just did. Find the number of non-negative integral solutions of the equation. Non-negative, that means 0 or higher, right? Cannot be negative. It can be 0, 1, 2, but integer. Okay, so that means 0 or a natural number. So that is what the formula was for. 0 to 10, 0 to 10, 0 to 10. So we can directly apply the formula. 10 plus 3 minus 1, C3 minus 1, that is 12C2. Exactly the same problem as distributing 10 mangoes into 3 students. Now, positive integral solutions. Positive integral meaning natural numbers has to be greater than equal to 1. Now this is greater than equal to 1, this is greater than equal to 1, this is greater than equal to 1. Same as distributing the mangoes, distributing 10 mangoes into 3 students. But now, what is the condition? The condition is that at least 1 mango should go to each student. That is what this condition means, that at least 1 should be given to each student, and then the rest doesn't matter. How do we do it? By taking another variable, x dash plus y dash plus z dash is equal to 10 minus 1 minus 1 minus 1, 7. So 7 plus 3 minus 1, C3 minus 1, that is 9C2. Okay. So this is how, without thinking of any objects, thinking of any partitions, any students, we can directly solve an equation where we can have integral solutions with certain conditions. Alright. Now, find the number of non-negative, so 0 or higher, integral solutions of the inequality x plus y plus z less than equal to 10. How do we solve inequalities? If this were equal to 10, we could have done it. Now, one possibility is that we count all possible things, right? X plus y plus z can be 10, which will give 12C2, 9, which will give 11C2, 8, 10C2, or because they are non-negative, it can go up to 0. So that means 2C2. So like this, and we can add them up. Clearly sounds like a lot of work. There must be another way of looking at it. There is. Now, x plus y plus z. We have 3 non-negative integers and their sum is always less than equal to 10, right? That means if we subtract 10 from x plus y plus z, we subtract x plus y plus z from 10, this will always be greater than equal to 0, because this is either equal to 10 or smaller. If we subtract this from 10, this will always be non-negative. It can either be 0 or a positive number. That means if we take this as w, if we take this variable as w, that means 10 minus x plus y plus z is equal to w, or 10 is equal to x plus y plus z plus w, where w can be greater than equal to 0. W can also go from 0 to 10, right? Because if x plus y plus z is 0, it is still less than equal to 10. In that case, w will be 10. So now each of these will go from 0 to 10. Now we can apply our formula. How do we apply the formula? Now we have n equal to 10, r equal to 4. Because now we have 4 variables. So n plus r minus 1, c r minus 1. So that is 13c3. Alright. So even if you added all of these, you would still get 13c3. But an easier way of doing this is by adding a quantity. If this is smaller or equal to 10, less than or equal to 10, that means if we add another quantity w, then it will be equal to 10. Whatever is missing, that is making it smaller, we just add that quantity. Now it can be 0 or 1 or up to 10. Alright, so like this we will solve such inequalities and then it becomes our usual problem. This will count all possible cases. So number of non-negative integer solutions of x plus y plus 2z is equal to 20. Now we cannot apply our usual formula, right? Why? Because there is a 2 here. Even if we replace this by another variable, now it's not like it can go from 0 to 20. It will go from 0 to 20, but only even numbers, right? 0, 2, 4, 6 and so on up to 20. Not all possible natural numbers, right? So we cannot apply our formula directly. Even if we split it into 2 z's, even then there is a problem. Why? Because the first z and the second z have to be equal. But if we count all possible cases for these 4 variables, it is possible that this is 7, this is 5 and this will be counted. But that cannot happen. They have to be the same. So how do we do this? We do this using the multinomial expansion. So yes, answer is C. That is correct. That is correct, bache. Let's take a look how we can use multinomial every time and it will always give us the correct solution. Okay. So for the first 2, we have all possible 0 to 20 options, right? So now we have x plus y plus z dash is equal to 20, where z dash for x plus y, we have x raised to power 1, x raised to power 2 up to x raised to power 20. That is the possibility for both x and y. But for z dash, we have 1 plus x raised to power 1, x raised to power 2, 0, 2, then 4, then 6 up to x raised to power 20. And we have to find the coefficient of x raised to power 20 here. This is a GP, this is still a GP. What is this GP? This is simply 1 minus x raised to power 21 square 1 minus x raised to power minus 2. Here we have 1 minus x square. X square is the common ratio. How many total terms? 0 into 2, 1 into 2, 2 into 2, 10 into 2. So 0 to 10, 11. So in total we have 11 terms here, divided by 1 minus x square raised to power minus 1. Alright. Now we need the coefficient of x raised to power 20 here. X raised to power 20 here. Again, from here we will only take 1, because the other x raised to power 21 or x raised to power 42, they are all greater than x raised to power 20. So we will only take 1 from here, and we can ignore the rest of the bracket, rest of the expansion here. Similarly, here 1 minus x raised to power 22, from here as well we will only take 1. So now we have our new problem, x raised to power 20, the coefficient of x raised to power 20 in 1 minus x raised to power minus 2 and 1 minus x square raised to power minus 1. Correct? Is there any discussion? We can put z0 to 10, then solve every time adding them up. Of course, Bache, that is what you can do. Of course, if you want to count all of the cases, you can. But the problem can be when it's a big number. We don't want to rely on manual counting. We have maths at our disposal. We have to learn how to handle the largest of numbers, right? That is why we learn this method. Of course, that is also correct. If you just put this 0 or directly here 0 then 2, so for x plus y you will have x plus y is equal to 20, so 21 ways. Then for 2 there is x plus y is equal to 18, that means 19 ways, and so on till 1. So this will be equal to 121. The sum of first 11 odd numbers, that is 11 square, that is 121. That is absolutely correct. But it's important to learn this method so that you can apply it in any scenario. Okay, you don't have to count all the possible cases. So now we have to just find x raised to power 20, the coefficient of x raised to power 20 in this expression, right? Here we again have to do some case handling, yes. Just a second, we are So again we have to do some hard work. If there is just one expression, then it becomes easier, but in this case we have 1 minus x raised to power minus 2, 1 minus x raised to power minus 1, 1 plus x raised to power minus 1. So that is 1 minus x raised to power minus 3 and 1 plus x raised to power minus 1. How do we solve such problems? Again, if you're new to binomial, multinomial expansions, you might be getting some confusion, which is why I suggest that don't start here. It will only confuse you more. Study binomial first and then look at these solutions. But coming back, 1 plus x raised to power minus 1 is this. Alright, 1 minus x raised to power minus 3. This is being multiplied and we need x raised to power 20. We need x raised to power 20 as a product, which means if we take 1 from here, then we need x raised to power 20 here. That will be 20 plus 3 minus 1. Right, 20 plus 3 minus 1, see 3 minus 1. Then we take 1 from here, x. Then we need x raised to power 19 from here. So, minus 19 c 21 c 2 plus x square. So now we have 18. So 20 c2 minus 19 c2 and so on, right? Now let's take a look at this. 22 c2 minus 21 c2. We have this 22 c2 minus 21 c2. If you know the property, bache, 21 c1 plus 21 c2 is equal to 22 c2. That will always be the case. If we have NCR plus NCR plus 1, it will always be n plus 1 CR plus 1. If you don't remember the property, we can just expand this 22 factorial by 20 factorial 2 factorial minus 21 factorial 19 factorial 2 factorial. We take 21 factorial by 20 factorial 2 factorial common. What do we get from here? We only have 22 remaining because 22 into 21 factorial, that is 22 factorial. From here, we have to multiply it with 20 to get our 20 factorial in the denominator. So that means this 2 gets cancelled with this 2 factorial and we have 21 factorial by 20 factorial into 1 factorial or directly 21. So 21 C1 or directly 21. So from here we get 21, from here we get 19 and like this from the next 2 we get 17 until 1. So now we have, yes, the same kind of expression now, which is sum of all odd numbers. It's an AP where either you can say we have first 11 odd numbers, which directly comes out to be 11 squared, or you can apply the formula of sum of AP, which is 11 terms by 2 into first term plus last term. So that is again 11 squared, which is 121. But this is, bache, how you apply multinomial in any scenario. Okay, just have to keep expanding and checking how we can find x raised to power 20 here. I suggest you revise this after the class. It might be a little complicated for you if you're doing it for the first time, but if you know binomial expansion, then you must be able to follow all of it. Alright. Now, last question of the day. This class went longer than usual, right? But it's an important topic. It's a very important topic even when it comes to IOQM or JEE. This is a very important topic, which is why we are taking enough time to understand this. Okay? Now, the last topic. In how many ways can a 12-step staircase be climbed, taking 1 step or 2 steps at a time? That means we have a staircase. There are 12 steps. We can either take it 1 step at a time, or we can jump 2 steps directly at any point. At any point, if we are here, we can either go here or we can directly go here, take 2 steps at a time, jump 2 steps up at a time. Okay? So that means we have to count all possible ways of doing this. Now there are 2 ways of looking at this as well. First is, let's say while going, I took X single steps and Y double steps. So now X plus 2Y is equal to 12. But we won't just count how many possibilities of X and Y are there, because if this goes from, let's say 0, then 2, 4, 6 up to 12, right? Now for X, we know there's only one possibility. In each case, there's only one possibility for X. So 0 to 12, that means Y can go from 0 to 6. So total 7 cases. But that's not all the problem. For example, if we take 10 single steps and 1 double steps, that means that is not one case, because we don't know when we took that double step. We either took it at the very beginning, or after 1 single step, or after 2 single steps, or after 3 single steps. So that means we'll have to check each of these cases, right? So now we have to arrange these. So how do we arrange these? For this case, we have, well, one case, but how do we get there? 12 factorial by 12 factorial, 0 factorial. For this, we have 12 factorial, sorry, 11 factorial by 10 factorial, 1 factorial. How did we get this? Because we had 10 single and 1 double. So we had to arrange these. That means we arrange 10 plus 1 divided by 10 single are identical, and then 1. Similarly here we have 8 plus 2, 10 factorial by 8 factorial, 2 factorial. So what is this? This is 12C0, this is 11C1, 10C2, and like this we'll keep adding. So what is the sum? 12C0 plus 11C1 plus 10C2, 9C3, 8C4 plus 7C5 plus 6C6, and that will be the last case, right? Last case we have 0. That means we selected 6 double. Out of those 6, we have to arrange 6 factorial by 0 factorial, 6 factorial. So 6C6, and that is our last case. All 7 we have listed here. We just have to add them up. So we add them. 1 plus 11 plus 10 into 9 by 2, that is 45. 9 into 8 into 7 by 6, that is 84. Plus 8C4. 8 into 7 into 6 into 5 by 24. So that is Okay, now I have to write down. 8 into 7 into 6 into 5 by 24. So that is 70. Plus 7C5, that is also 7C2. So 21 plus 1. And we add these up. A lot of calculations, yes. We are checking ma'am's math calculations. So 12, then 57, 141, 211, 232, 233. Right? So this is one way of doing it, okay? One step at a time. Let me just go through it again, the entire solution. What did we do? We first checked how many single steps are there, how many double steps are there. And then we have to arrange them. So, how many single steps and double steps? We first fix the double steps. So, that means double step is 0 or 1 or 2 or 3 up to 6. And the remaining will be single steps. So, 12 minus 0, 10, 12 minus 2, 12 minus 4 and so on. And then we have to arrange these x and y steps. So, x plus y factorial, cy or cx. Okay. So, this is one way of looking at it. Another way of looking at it, a very important thing to learn, bache, if you're preparing for the Olympiad, is a way of writing such cases. Now, we don't know how many possible cases are going to be there up to 12. But we know that if we had these 12 steps, then for any point, let's say this is the 12th step. To reach here, I could have taken either this is 11th, this is 10th. I could have taken either a direct jump from 10th or a direct jump from 11th. So let's say there are T12 ways of reaching the 12th step. We can say that this is equal to either we take one step from 11th. So in how many ways could we reach 11th step? T11. Okay, so there were T11 ways of reaching the 11th step. We can, if we have reached here, then we can just take one step and 10, 11 into 1. Or we can come from T10. From 10 steps, so that means once we have taken T10 ways of reaching 10th step, then we just have to jump once. So there's exactly one way of reaching 12th step from 10th to 12 directly, or we can go 11 and then we can come from 11. Okay, so that will be true for any step. For nth step, it can either come from n minus 1 or it can come from n minus 2, and we will add all the possible ways of reaching this or this, and then this will be the total number of ways of reaching nth step. So for example, what is T1? We started from 0th. How many ways to reach the first step? We have to take a single step. How many ways of reaching second step? We can either jump from first step, we can go from 0th to second, or we can go from 0th to first, then first to second. So there are two ways of reaching the second step, right? Either we go directly, we are on the 0th step. So we either jump directly to second or we take it one step at a time, right? Exactly two ways of reaching second step. Now that means for T3, how many ways are there? We are saying it has to be T1 plus T2. But let's confirm where we are getting this from. Let's say we were at 0th step, and then this is first, this is second, this is third. right? We can either go this way, one step at a time. This is one way, right? This is exactly one way. We go from 0 to 1, 1 to 2, 1, 2 to 3. This is one way. Another way is we go to 0 to 1 and then directly from 1 to 3, or we go directly to 2 and then to 3. That means once we have reached the second step, either the yellow route or the green route, once we have reached the second step, there is exactly one way of reaching the third step. And how many ways of reaching the second step were there? Either the yellow route or the green route, which were the two ways. If you forget about the third step, there were two ways of reaching the second step, right? There were two ways of reaching the second step. That means after we have reached, there's only one way of reaching the third step. Or if we are not going to second step, we are coming directly from first, then how many ways were there of reaching the first step? There was only one way. So either we take the orange route or we take yellow or green. Now, bache, you might say that once we have reached the first step, there are still two ways of going to the third step, right? We can either go to second and then to third, or we can go directly to third. But if we are counting that step again, if we are going to second again, then we are counting it twice. We don't want to repeat any case, right? So that is why once we are checking the last two steps, we are either checking that you take a single step to reach here, or you take a double step to reach here. So if you take a single step to reach the nth step, that means there are tn minus 1 ways of doing it. If you take a double step to reach to tn, that means to nth step, that means there are tn minus 2 ways of reaching the nth step. Okay, so this is called a recurring relation. So like this, we can find all tn's, and finally we need to find t12. So t1 is 1, t2 is 2, t3 is 3, t4 is, we just have to add the last two and we get the next one. So 2 plus 3, 5, t5, 3 plus 5, 8, t6, 5 plus 8, 13, t7, 8 plus 13, 21, t8, 13 plus 21, 34, t9, we add these, then t10, we add these two, so 89, and t11, 144, t12, 233, which is what we were counting. How many ways of reaching 12 step are there, which is what we found in our previous method as well. So both methods are correct, both methods are giving the right answer, but it's important to know both the methods, understand both the methods, so that you can apply any of these in your problems. Sometimes this might be helpful, more helpful, sometimes the other one might be more helpful. So you have to know everything to score the best you can. Okay, if you study half of the syllabus, if you study half of the methods, then you are only aiming for half of the solutions, half of the correct answers. But if you study everything there is to study, then your chances, your probability of scoring maximum marks increases. Okay, so we learned a lot of new things today, I'm sure, for a lot of you. So I will suggest that you go through everything again so that you understand it for life. Even if you understood everything in this class, I'm very happy. If you understood everything, you're on the right track. But this is my one tip forever. For every class you attend, not just with me, but with any teacher of any subject, it's very important to revise. That makes sure that you remember everything. Even if you think you remember right now, even if you think you will remember it for a few days, but their chances of forgetting increases if you don't revise. So as soon as you revise, it's just the human brain, that's how it works. as soon as you revise, it retains better. So take it from me, it is always better to revise. That makes sure that you will never forget this even after years, just like me. So please revise everything we cover in every class, and I will see you in the next class with even harder topics, even harder problems. So make sure that you understand everything so far. Only then you will be able to follow the next classes. And yes, at the end of the course, we will go through all types of PYQs from IOQM and even some JEE problems that I feel will be helpful for you. So first we will finish the entire course and see some problems, and then we will apply all of these things in combination with each other and see how it can be used to solve the hardest of the PYQs, hardest of the JEE problems, hardest of the problems out there. Okay? Okay, no voice? You sure? Because it seems like the mic is connected. So maybe your device has some problem, bache. Anyway, I will end the sound low. Okay, I don't know. Must be some problem, but anyway. This class went on for quite some time, but they were very important topics. I hope this was very helpful for you. I'll see you in the next class. Make sure you revise everything, and I think the next class will be on the weekend. Okay, so you have enough time to go through all of the previous lectures, revise everything so that you are not confused in the next class. Bye.